Hey, what's up? Hello, everyone. Welcome back to my stream. And we are today at season 3, episode 4. And the whole season is dedicated to options trading and especially one particular strategy that's called wheel. And today we are going to continue on backtesting and tuning its parameters. And what we did last time, if you remember, we we changed the strategy a lot. So we added the dynamic where is it here, adaptive call delta. So basically it was dynamically chosen based on what's the current price during the purchase. And if we are underwater, then we put the lowest delta. If we are break even, we put the like mid delta, profitable more, and then we have also a skip threshold that should be skipped if we put a second. Yeah, it didn't work before. So which yeah, so basically if we are underwater, then we put the lowest possible delta, but if also the premiums are small, then we don't trade at all. So we just check like if there is at least some good premium for us even though we are underwater. So that was the point. We did a little bit of restructuring and refactoring over here, and we did Monte Carlo simulation, which is basically we run by default 200 times random, but deterministic random tests on our strategy, and then we calculate the win rate, the mean APR, the median APR, mean PNL, and mean max drawdown over here, and we place the charts for them as well. So I guess I'm gonna open the window. I don't know, like I feel that there is not enough oxygen. Give me a second. Okay, I'm back. So plan for today is as usual. We just go with the flow. Fix whatever happened on our road, and analyze everything again and again until we are sure that this is worth running, and then we will start implementing the bot eventually. So let me take a look at the notes I did last time before we finished. So for visualization, show the assignment price, entry and exit on the chart. This is actually cool. Probably I made a mistake, like, because assignment price is always like this line, because this is a strike price basically. So probably doesn't make any sense actually to do this. We already see it here. Like this is a yeah. You got it. So yeah, probably this doesn't make sense. Like now, looking freshly at it, I think it's okay. Bugs. Check if premium threshold is actually working. Yes, this is what we need to check definitely. Here is the strategy changes, but I think we can remove those. Simulation when strategy is perfect for wow effect backtesting on real prices. Yes, this is what we're gonna do later. I will just add here for wow effect or no. So we have ideas, some about exiting early, stop loss and take profit. Okay, this is makes me also idea for a future iteration. Okay, so yeah, sorry, I'm just I need to get back to the context as I told you before, so that's why I'm just a little bit slow at the beginning, then I'm speeding up. So I think the best way for the context will be now just look at it again from scratch, just verify that all the calculations everywhere works or not, and we will see. Because I think I remember last time the question was why we chose like to sell here, or how much we earn. I think we could just check it like this. If we move it here, then we don't sell it, right? So then on the next week we sell it here. And now, like, we are already interesting. This first simulation, the first seed, basically the price is like never going up here, so the APR decreases a lot. So this is the point where we should have closed it. I think. But also theoretically we could have sold them here. Also. There's so many options. Yeah. But let's start slowly. Let's go one by one. Okay, so apparently this threshold works, I think. We just because here you can see we sold call on day 14. We sold it for do it like this. So the premium is $45, which is quite a lot. Which is like $45 based on the Ethereum price, or like 2.25%. This is why like all the way here it was never excluded up until the 2 here, which is okay. 175 is here, 1.8 here, 185 still here. Okay, so apparently it was like something like this, I think. Yeah, so it was like yeah, this one. So it was like 200,200. Yeah. Okay. So I think it works. So we can remove this bug. Sure. So let's take a look at this show assignment price entry exit on the chart. I think it's also just these lines. I was just confused last time. Basically here we go and we buy ETH right at the entry prices to 377, which is like our strike price, which we have here already. This is where we buy and this is where we sell. We can definitely use those as yeah. So this is done. Okay, fresh looks are also helpful, of course. Like I'm a bit slow now, but still I can freshly look at the situation and see what I haven't seen the last time. Okay, so let's go back to calculations. I think these two myths were busted, and now we can continue on our strategy. So let's go back here and see what happened here. So we lost immediately, and let's remove those. I think add waiting points to not always trade, but only when the market position conditions are good. This is what we are doing basically. So I'm removing those completely, and maybe relate to previous simulate again to assign call at lower price and fix. Yeah, this is the same. So let's remove those. Simulation. Yeah. Okay, and some strategy ideas for the future. Okay, so we basically have a clean backlog here. Nothing to do right now. That's why I think let's just continue over here and write down our insights. And then we will move them to the tasks from the insights. So yeah, so first idea here is like first insight or idea. Just explaining like what is the difference here. So first insight, yes, is to just increase the skip threshold. So let's see, to not sell calls at lower premiums. So basically, yeah, basically this situation that we just saw, we could have mitigated, but also we need to see like what are the effects of that, right? So we will take a look at different simulations. Okay, so we have this one here. So let's take a look at this one. This one is better. It's not losing, even though like it's coming back from time to time. As you can see, because of the premiums, probably. Yes, it's just. Or wait. Oh no! It's just because of the. Yeah, okay. So this one, I forgot. I thought this one shows unrealized. Like this one shows unrealized. This one shows the total. So I was wrong back before when I told that we could have sold there. So this is basically the chart when if we just sell Ethereum immediately, what are we at? And here we are just at break even, which is bad. Like this situation is, I mean, this is okay situation because like we decided that we are gonna hold Ethereum, right? So this is not a problem. So there are two parts. They are completely different because of the different views on the market, selling puts and selling calls. And basically, we are only selling calls when we have ETH because we want to sell it, right? So we have like also two different situations when we hold cash and we hold Ethereum. And imagine we just hold cash. So we want to buy Ethereum at lower price. That's why we are selling puts. So is there any um optimization to sell puts better? I think no, because we discussed it last time, but let's run it again. Just I think it will be interesting. Review the wheel strategy and suggest improvements. Strategy is consist of two phases: holding cash, selling puts. And another one after assignment, holding asset, last selling calls. What are possible improvements? For example, I'll just give it examples. For example, like better way to sell puts, better way to hold cash. This is interesting. I mean, why not? Like additional API or something, but yeah, it's not about holding cash, of course. But yeah, let's just keep it. After assignment, holding assets, plus selling calls. What are the other options? Floor and the group options, not options, but recommendations by some categories and impact. Let's see. So what we did here, let's go back again while it's thinking and preparing something for us. So we sold put, we got our premium. It was our P&L. Then we were not assigned or whatsoever, and then we sold another one with a slightly lower premium, which got us another $85, which was 172 in total P&L at the time. Then we purchased Ethereum here because we were assigned. So at the end of the second period, we purchased Ethereum at a slightly lower price, but it doesn't matter. It doesn't affect our P&L much. If we take a look at if we are not selling it, so we dropped immediately here. to this difference. And then what happened then? Then we sold another call, so we earned more premium on the day 14, right? Here is the one. And we were like already plus 200 by premiums, but we were at the same time um, minus 400 by unrealized PNL. And then the price of an asset just went up. So our yeah, so on the day 20, our PNL was actually positive. But it never went up to the point of where we purchased it. So it was like never positive actually. You can see here on the day 20. On the day 21 it became zero, not because yeah, just because we sold it and it just reset. But we sold it at a lower price here. So like sell the E's, you can see we got like minus 300. By then we were already plus 200. That's why so yeah, we were minus 95, 85, 89 here, but then we got $73 in premiums for another put. And that's why we got into minus 16. But then the put was assigned, so we purchased it. Again, we'll just prolong it to 60 days and see. On the 60 days run, we actually never recovered from this. And so like it's 62% win rate, but still what if we make it 30? Okay. Our goal here is to increase the win rate, I think, and that it's also regardless of the so total PNL is slightly bigger here just because it still does not calculate the unrealized PNL, which is always below zero. What about next seed? This is already a different situation. Okay, so let's take a look what was offered here. I think it finished with the analysis. So build strategy improvements, put selling phase, cash secured. So high impact are dynamic delta based on IV rank percentile. Sell higher delta, closer to at the money. Puts when IV is elevated. Reach premiums compensate for risk. Lower delta when IV is low. Currently use a fixed target delta regardless of volatility regime. Then DTE ladder rolling. Instead of fixed 7-day cycles, consider selling at 3045 DTE and rolling at 1421 DTE. Theta decay accelerates after 21 DTE, but before that you can carry gamma risk with the less theta compensation. Rolling captures the theta sweet spot repeatedly. Okay, here is some more advanced option magic over here. So keep this one for now. Let's read all of them. So the medium impact is cash secured versus margin secured sizing. Currently one contract at a time could sell multiple puts at different strikes expirations to create a put spread ladder or scale position size based on portfolio delta or max loss tolerance. Um, hmm. I don't know, like for me, I thought to not use any leverage actually, just because, like, you know, in worst case scenario, if you don't use leverage, then you just purchase Ethereum. But here, if you use leverage, then you need to purchase 2 Ethereums, which is like a different risk already. Like you take 2 times the risk, and so on and so on. So this is the question, but we may explore this as well. Let's just read through the rest of those. Put spread instead of naked put. Buy a further out of the money put as a protection. Sell 30 delta by 10 delta. Caps max loss. Reduces capital requirement at the cost of some premium. Oh yeah, this is what I like actually. Um, Lower impact. Avoid selling puts before known events. Like skip cycles around earning equivalent events, major protocol upgrades, macro events where realized volatility is more than implied volatility. Interesting. Yeah, this is what actually was in my list of just wait a little bit and do not sell. But it was about call options, but it's actually like I don't know. This is a questionable for puts because still, like, if I am willing to take Ethereum risk, then why cares? Why caring? Like, if especially if the realized volatility will be higher than implied, probably the prices will be better. So, uh, Avoid selling puts before known events. Yeah, okay. So, and the IV implied volatility surface, skew awareness. So puts often have a skew premium. Could target strikes where skew is steepest for better risk-adjusted premium. Okay, interesting. Let's take a look at the calls. So call selling phase. High impact. Roll up and out instead of waiting for assignment. That's interesting. When a call goes in the money before expiration, roll it to a higher strike. That actually totally makes sense. Plus further DTE, day to expiry, or a net credit. This avoids forced selling and captures more upside. Your current sim just waits for expiry. Okay, this is actually a very cool idea. I think it's pretty easy. Sell calls at a cost basis strike premium. Never sell a call below your put assignment price, entry price. This guarantees no loss on the stock leg if assigned. Currently, the adaptive delta could theoretically select a strike below entry in a crash. But if we will apply the first option, then the second option probably doesn't make sense. Because, like, we can always roll. I think we can always roll. We'll see. Like, okay, we'll ask a question about it. Next one is minimum impact. Staggered covered calls. If holding sorry, I just get distracted sometimes. I'm back. Okay, so medium impact is staggered covered calls. So if holding multiple units, sell calls at the different strikes dates, some closer, some further, diversifies assignment risk. Makes sense. Like right now, I don't even know if the assignment is a risk anymore. I forgot about the rollings, and I think probably this is a good idea actually to just roll them. But I'm not sure like if it's like always possible, but should be like at some point. I mean, you can get like a lower strike price even, but you can delay, I think, this. I don't know. We'll discuss this. Like, just let's continue. Keep calls in strong uptrends. When the asset is trending strongly up, above 20 days moving average by percentage, consider not selling calls at all to capture the move. You skip logic is premium based. Trend based skip would be more strategic. Trend based skip would be more strategic. Okay, got the idea. Not sure yet, but got the idea. Lower impact is the color strategy when underwater instead of just selling low delta calls. Also buy a protective put. Creates a color that caps a further downside. Especially relevant when unrealized loss exceeds a threshold. Okay. This all impacts basically on the decision when and why to sell. So we are like, we will have 4 gates. Sell put. Yeah, where we need to have like 4 gates for the entering the positions and for exiting. And depending on these gates, we will be executing actions at some point, like signals. Okay, let's take a look at the rest. Position management and risk. High impact is max drawdown, stop loss rule. So if unrealized loss on the E's position exceeds the X percentage, cut the position instead of hoping for recovery via call premium. The correct strategy has unbounded downside during the holding phase. Yeah. Well, probably it's not for us. Like as we discussed, this is a strategy for holders, so maybe maybe not for us, but okay. Position sizing based on Kelly criterion or risk budget. Size the numbers of contracts based on edge premium risk ratio rather than a fixed number. Reduces exposure when premiums don't justify the risk. I don't know. Portfolio level delta management. Track the net portfolio delta and adjust strategy to stay within the target range. If you're holding E's and selling calls, your net delta is positive. If it gets too high, reduce exposure. So, yeah, this actually makes sense. Probably, I think it's related to the others. Okay, let's get to the. Wait, I didn't have finish with the medium impact, right? Capital efficiency tracking, track the current track rate with return on capital deployed, not just P&L. I put that ties up to 200, 2500 for 50 premium is different from one that ties up. Uh, Assignment cost averaging. If assigned on a put and price drops further, sell another put at a lower strike when assigned again. Yeah, this is more aggressive. Okay, volatility and pricing, the next category. The high impact is use realized volatility versus implied volatility spread as a signal. If the implied volatility is more than realized, premiums are rich, more aggressive selling. When implied volatility equals to realized volatility, then premiums are fair. If be selective. You have IV premium percentage as a static parameter, but this could be dynamic per cycle. Yeah, I didn't like this parameter actually, so because I never turned it. We can actually use this one. Stochastic volatility model. Replace constant volatility GBM with a model like Heston or Saber. Real Crypto volatility is mean reverting and clustered. This would make your Monte Carlo results more realistic. And medium impacts are volatility, term structure. Different days to expiries have different implied volatilities. A 7-day option and 30-day option don't share the same volatility. Modeling this would improve strike and day to expiry selection accuracy. Jump diffusion. Crypto has fat tails, sudden crashes, pumps. Adding a poison jump process to GBM with better model. What's GBM? The context of options and quantitative finance, GBM stands for geometric Brownian motion. It is a continuous time stochastic process used to model asset prices, such as stocks, by assuming that percentage changes in price are normally distributed. Okay. Simulation and analysis. High impact. Benchmark comparison. Show wheel returns versus buy and hold on the same price path. This is the key question. Does a wheel add alpha or just reshape the return distribution? And Sharp Sortino ratio. APR alone doesn't capture risk adjustment returns. Add return volatility and return downside volatility to Monte Carlo summary. Medium impact is regime conditional analysis. Breakdown results by market regime. Bull, bear, sideways. The wheel performs very differently in each. Could use drift sign or realized return over the period. Greek's evolution. Track portfolio delta, gamma, theta over time. Theta is your income. Gamma is your risk. Visualizing this helps understand when the strategy is least exposed. Correlation with underlying. Plot strategy, PNL versus underlying return to show the payoff diagram across scenarios. Show where the wheel wins, loses versus holding. And lower impact are transaction cost, sensitivity. Sweep, bid-ask spread, and fees to show how costs erode returns. Helps determine minimum viable premium. An optimal parameter search. Grid search for optimization over delta day to expiry. Adaptive params to find the Pareto frontier of return versus risk. Yeah, this is actually really cool. So the summary by impact is highest impact improvements for put selling are dynamic delta based on IV regime. Call selling is roll up and out instead of taking assignment. Risk management. Yeah, by the way, probably we can do the same with puts, but we can check this out. Risk management, max drawdown, stop loss rule. And pricing, IV versus RV spread as a trading signal. And analytics, benchmark versus buy and hold comparison. The single biggest gap in the current implementation is no comparison to buy and hold. Without it, you can't tell if the wheel is actually adding value or just trading upside for income. The second biggest is no early exit rolling logic. Real wheel traders almost never just let options expire, they actively manage positions. This is important. And we were talking about exiting early here and stop losses, for example, and take profit. Take profit is also a potential thing, I think. Okay, let's write down all of these into a file, improvements.md. Let's write down all of these as actionable points or checkboxes into improvement.md. We will be later having discussions based on it and also implement the ideas and use it as a plan. I would like to implement one of those. Let's walk through them again, but first I would like to do something else as well. I think it's time when we need to do a little bit of refactoring, but not really refactoring, but also maybe restructuring or like reimagining of how this works. But yeah. Okay, we have it here now. Let me just commit it so we don't lose it. Come on. Haven't written a commit message for almost a year now with my hands. Okay, so what I want to do is actually like talk more about the signals and restructuring. Like, before we grow our strategy logic any further, there I was thinking to review and think about how it's currently structured, as eventually I'm going to use the strategy in production and the trade with it. So I want it first to be easily transferable, reusable in execution engine, also more easily debugging, also to be more easily debuggable, let's say like this, and also more easily observable, and so on and so on. So one of the ideas was to implement actually a trading signals instead, and consolidate the rules we have now and the ones we will have. I will be having into those signals that basically manage the position. What are your thoughts on this and suggestions? Okay, we have the output actually. I was reading its thoughts, but we got the output. Let me read through this. So good timing for this. The current simulate wheel is a 190 line monolith that mixes three distinct concerns into one loop: decision logic, what delta, whether to skip, strategy brain, execution, BS pricing. What's this? Black and Scholes. Bullshit. Assignment, determination, the exchange, state management, the bookkeeper. Early improvement from improvements.md would mean modifying the same function and none of it would transfer to production. Here's what I propose. Signal-based architecture. Core idea is split the system into 4 layers: rules, why, strategy, what, executor, how, and the state record. And rule is basically a named testable condition that may produce a signal. Wait. Signal is a data object describing an intended action, not the action itself. Executor turns signals into fields, events, simulation or live, same interface. And the state, the portfolio plus event log, updated by execution results. Okay. The state machine. The wheel has 4 logical states and signals drive transitions. Idle cache, sell put, short put. I don't understand its writings here. Okay, so if you're in idle cache, then you can get a signal sell put and get to the short put state, I think. If you're in the short put state, there are 2 signals. Expired out of the money, then idle cache. Expired out of the money. Yeah, so basically we are not assigned. Okay, and assigned holding ETH. If we are holding ETH, then we sell call. Then we can receive a sell call signal. Then we can become a short call. And holding ETH, we can receive a signal close position, which is we sell we sell the asset and we are back in the cash. Stop loss. Okay, it's a future. Okay, yeah, we don't have it yet. And then the next one is if we are short call, then if we're expired out of the money, then of course we are holding ETH, so we can still keep selling the other calls. If we are assigned, then we sell our ETH and we are idle cash again. And if we will add rolling for the future, then we will have a roll signal that will roll it to the short call again. Currently, the code jumps from short put, assigned, immediately open short call in one step, making the holding ETH state explicit. Creates a decision point where rules can evaluate whether to sell and call, skip, close the position, etc. So yeah, if we just hold Ethereum, don't do anything. So concrete types, what the strategy sees, market snapshot, day, spot, and IV. What the strategy knows about itself. Idle cash, short put, holding ETH, short call. Cash number, position, size, entry price, open position, open option, rules or independent units. Each rule is a pure function with a name. This is where all the improvements MD items live. Okay. So each rule basically just gets the market data and signal out of it or not. Current logic maps to 3 rules. Future improvement become additional rule. Base put rule. Rules are evaluated in priority order. First, close position or skip. Queens over sell. This means rule interaction explicit and debuggable. Executor interface is critical part for production stability. Simulation and live share the same contract. Simulation executor uses prices, block and show pricing, deterministic assignment, and their bit executor uses API, real order book, actual fields. Yeah. Simulation loop becomes trivial. What this gives you? Debuggability. Every decision is a signal with a reason field. You can log day 14, adaptive call rule, and trace exactly why each trade happened. Observability. The signal log and event log are separate from the state. You can visualize signals on the price chart, colored markers for each signal type. Build a rule attribution table showing which rules fired and how often. Track rule hit rate across the Monte Carlo runs. Production transfer. Write a Deribit executor that implements the same executor interface. The strategy code, all rules, and the state machine are identical. Only the executor changes. Yes, this is what I wanted. Testability. Each rule is independently unit testable given this market snapshot and portfolio state. So does stop loss rule emit close position? No need to run a full simulation. Trade-off. The main cost is that the refactor touches wheel.ts and Monte Carlo.ts and the simulator UI, which reads simulation result. It's a structural rewrite of the engine, not a patch, but doing it now before adding more rules is exactly the right time. The current 3 rules are easy to migrate, and every future improvement will be dramatically easier to add. Want me to plan the implementation, or do you want to discuss adjust the architecture first? Write down the detailed, write down your research and detailed no code, or like write down your research reasoning and implementation plan into implementation plan.md. Why I'm doing this? Because I want to add a couple of rules first before we start implementation, and I think we definitely need to do this right now because yeah, you see the reasons, like it's getting bigger now, and the earlier we catch it, the better. I want to add additional skill here, so let me find the project where I wanted to get it from. I think I have one. Okay. Yeah, I think the scale is also, I don't know if Claude actually. We would expect them to be at this location, I guess. Okay. I think we need to transfer this one to .cloud/skills. Probably this is a bullshit skill, so we. Okay, let's keep it. So what we've got here, all these files renamed. Okay, let's add it. And also the plan. Okay, I think it's good. Let's check the skill that I added. So the skill is about just maintaining the documentation basically, and let me show it to you. So it's just um, there is always like docs folder. If docs and code disagree, default to making code match docs. If behavior must change, update docs first or in the same change, and call out the intentional contract change. Workflow, discover relevant docs, decide whether a docs update is required, choose a doc location, and write and update docs. Output expectation: when you create update docs, mention which docs files changed and what contract changed. Where is it? Yeah. So I prepared this before, it worked. Let's just keep it. I think it should work here as well. Also, wait, I also wanted to update the agents.md. What we have here now. And agents.md is useless. Let's define a new one. So what should it have? I think I can even reuse this one. Let me take a look. One thing. 1 second. Okay, I'll put 2 of the files I have. And as a reference, I'll just ask it to use them. Also, what we need to do is to add the file like this, which is to reference. Maybe we can add it. Okay, it says we can delete all these. Let's do this, and also let's review. Let's keep it independent from the architecture docs. See the skill for docs. I'd rather turn those. So I'd rather take all useful stuff rules from the reference, but the docs will be written separately. Already much better, but still some stuff belongs to skills. Observable and the docs. Change the skill to include all those necessary info. Okay, now use the docs skill and write basic docs and the domains if needed to fill to make the initial fill of the docs with the current state of the code base before we will start refactoring. So just some preparations. I think we can remove those already, and also Claude will be removed. We have our first documents now, documentation about the project. This one describes architecture. The simulation. And the strategy. Very good. Two more things. First, update main readme. Make it meaningful and beautiful. And reference docs there. Docs readme there. And also make sure docs have info that there is a text visualization algo of the algo, and whenever there are changes in it, this text representation must be fixed too. Remove not needed there. I mean the strategy. And the necessity to update it. And remove. Okay, I think it's good now. So let's remove these references. And also basic docs, everything. We have the plan, we have the readme. What we need to do is remove these agents, or we can just put all the contents here to agents because it's more commonly used file. And with a cloud, we can just reference agents. Oh. Okay, I think we can commit this. No. I'll just ask it to commit. Oh, it's actually my first joint commit. I've seen those, but I haven't co-authored. Yeah. Nice. So, we are at almost 2 hours here. Probably we should stop. I know we did not implement anything, but we did actually analyze a lot. So, so for the next session, it will be first we will have the implementation plan, and then the implementation plan implemented, I mean, and then we will refactoring plus visualization. Or visualization of the new architecture. Signals, we make it observable, and then improvements, and then improvements. And improvements like, oh my god, like this. Discussion of different read through them again and discuss with the AI cloud. Read through them again, discuss with the cloud, and what else can we do? Implement those that make sense, compare win rates. Let's see. Yeah, so that's it. Okay, I think that's it for today. Thanks everyone for watching, and we are gonna continue on Friday, 3 p.m. Central European time as usual. We will start implementation. We will first start with the refactoring of what we have already, so we are not like late to refactoring later. So it's easier now to do it, and then it will survive the highest, like the more improvements basically. Also, it will have better visualization and so on, and then we will start working on these improvements, which are basically the improvements for the strategy, which should increase our win rate and mean APR and so on. And there are also could be a more additional outputs, basically, according to which we compare strategies and so on. I would like to reduce some of those params so they are dynamic and automatic. The less of those we have, the better, I think. Yeah, we will see what the future will bring us. But it's getting better. It's getting better. I think we are soon gonna be ready to start implementing this. I'm actually curious already to start using. I'm curious to start using this in production to start trading. So I'm excited already about it. So yeah, I want to start as soon as possible. But like I don't want to rush as well. So whenever it's ready, whenever we feel comfortable with it, we tested it on the real data. Then I mean backtest on the real markets, and we will try different starts. Yeah, let me write this down as well. When backtesting on real prices, try different starts. Let's see. Yeah. Yes, so I think that's it. Thank you so much again for joining today, for watching. Don't forget to subscribe, like. I have a Telegram channel, I have Twitter, I have everything in the description. You have a link with all my links. All the news are in Telegram, and whenever I start and so on. So usually it's Monday, Wednesday, Friday, 3 p.m. Central European time. Please join, and bye bye. See you on Friday.